Hi everyone, in this video we are going to discuss about how to calculate the trigonometric ratios of angles like 180 degree minus theta. So if we are given the angle 180 degree minus theta, we will try to find out the value of the trigonometric ratios of such angle in terms of the trigonometric ratio of the theta angle. So before we go into the calculation of the trigonometric ratios of 180 degree minus theta, let's make sure that we are very clear about the concept of cosine function and the sine function on a unit circle. So again, to do a quick revision here, if we have a point P on the circumference of this unit circle, and if OP creates an angle theta with the positive x-axis, then the x coordinate of the point P will represent the cosine function, and that will be cosine of theta, and the y coordinate of the point P will represent the sine function, that will be sine of theta. And that's the note I have made here. So if we are clear up to this point, then we should be able to move forward with the calculation of trigonometric ratios of 180 degree minus theta. So let me go ahead and plot a point Q on this unit circle where the OQ line segment will create an angle 180 degree minus theta with the positive x-axis. So let me plot the point Q on this circle. So I have plotted a point Q on the circumference of this unit circle, and I have not populated the coordinates of the point Q. I have left an empty parenthesis there. And now if you look at the angle 180 degree minus theta, which is the angle QOA or AOQ, that angle is 180 degree minus theta, then definitely QOB will be equal to theta, because one full straight angle will be 180 degree, and if the yellow angle is 180 degree minus theta, then the green angle will definitely be equal to theta, because their sum will be 180 degree, the straight angle, right? So now if you look at these two little triangles, the triangles OAP and OBQ, you see that their hypotenuse is of equal length, because it's the radius of this unit circle, which is again just 1 unit, but again they are equal, right? So OP equals OQ, and the angle POA is equal to angle QOB, because they both are theta angle. And similarly, the other angle, which is the angle APO and the angle BQO, they will also be equal, because they will be 90 degree minus theta. So now we have two little right triangles where the hypotenuse is of same length, and the two adjacent angles on the hypotenuse, they are also of equal size, meaning the corresponding adjacent angles are of equal size. So from the angle side angle axiom of congruent triangle, we can say that these two triangles are congruent triangles. So can we write it like this? So I have written here triangle OAP is congruent to the triangle OBQ, and because these two triangles are congruent, their corresponding sides will be of equal length. So from here we can say that okay, the length of OA will also be equal to the length of OB, and similarly the length of AP will be equal to the length of BQ. Again, these are just length, these are just numerical length without considering the sign. Now that Q is in the second quadrant, we have to be careful about the sign, but again here I am writing just considering the two right triangles. I am simply saying that their corresponding side length would be equal. So now what would be the cosine function of 180 degree minus theta? Well, the cosine function of 180 degree minus theta will be the x coordinate of Q, because we know that the cosine function always represents the x coordinate of the point. So now if we are talking about the angle 180 degree minus theta, and this angle is created by the point Q, then cosine of 180 degree minus theta will be equal to the x coordinate of Q. So let me write that down. And then what is the x coordinate of Q? If you look at the diagram, the x coordinate of Q is actually the length OB, however that is in the negative direction. So we can say this is in the negative direction, and then I am putting a modulus sign or absolute value sign to indicate that we are talking about just the length of the OB, right? So it will be negative of the OB length, and then if you look at our note up above, OB is actually equal to OA, so we can say this will be negative of the length OA. And then again, if you carefully look at it up above, OA is actually equal to cosine of theta, and that too equal to x. OA is actually cosine of theta, so this will be negative of cosine of theta. So we have been able to figure out the cosine of 180 degree minus theta in terms of a trigonometric ratio of the theta angle. So let me me make a quick note here. So now can we populate the x coordinate value of q? Well, x coordinate value of q is equal to cosine of 180 degree minus theta, which turns out to be negative of cosine theta, and cosine theta is actually x. So cosine of theta is x and this is the negative value. So we can easily write here, we can say okay, this is actually negative of x. Now let's try to calculate the value of the sine of 180 degree minus theta. So sine of 180 degree minus theta will be actually the y coordinate of the point q, and that is equal to the length bq, and that is again in the positive y axis direction, so it will be positive bq. Now as you can see, bq is actually equal to ap right here. bq is actually equal to ap, so we can write it as ap. And what is ap again? Well, ap is actually equal to the sine of theta, so this will be equal to sine of theta. So we have been able to calculate the sine of 180 degree minus theta, and the value turns out to be sine of theta, and that too positive sine of theta. And what is sine of theta? Well, sine of theta is again equal to y. So can we populate the y coordinate of the point q? Yes, because now we know that the y coordinate of point q, which is actually equal to sine of 180 degree minus theta, and that turns out to be sine of theta, which is actually equal to y. So I am going to simply write a positive y there. Because the point q is in the second quadrant, its y coordinate will be a positive value, so positive y would make sense. So now we have found out what would be the coordinates of the point q. Well, it will be negative x comma y if x and y are the coordinates of the point p that makes a theta angle with the x coordinate. So the coordinates of q will be negative x comma y when x and y are the coordinates of the point p that makes an angle theta with the positive x-axis. So let me make a quick note here. Now let's calculate the value of tangent of 180 degree minus theta. We know that tangent is the ratio of sine over cosine. So we can write it as sine of 180 degree minus theta divided by cosine of 180 degree minus theta. Now what is the value of sine of 180 degree minus theta in terms of the theta angle? Well, that is actually equal to sine of theta, that we have already calculated up above. And then what is the value of the cosine of 180 degree minus theta? Well, that is actually negative cosine of theta. So from here we see that this is negative sine divided by cosine, that is tangent. So this would be negative tangent of theta. So we have been able to calculate the value of tangent of 180 degree minus theta in terms of the ratio of the theta angle. So let me make a quick note. Now let's calculate the cosecant of 180 degree minus theta. We know that cosecant is the reciprocal of sine. And what is the value of sine of 180 degree minus theta? Well, that is actually positive sine of theta. Now what is the reciprocal of sine? That is cosecant. So this will be positive cosecant of theta. So let me make a quick note. Now let's calculate the value of secant of 180 degree minus theta. We know that secant is the reciprocal of cosine. So we can write it as, and then what is the value of cosine of 180 degree minus theta? Well, that is actually, let's quickly check, the cosine of 180 degree minus theta came out to be negative of cosine theta. So you can say this is negative of cosine of theta. So this will be negative of the reciprocal of cosine of theta, that will be secant of theta. So negative of secant of theta. So let's make a quick note here. Now we are left with the cotangent ratio. So let's quickly calculate the cotangent of 180 degree minus theta. Now cotangent is the ratio of cosine divided by sine. And what is the value of cosine of 180 degree minus theta? Well, that is actually negative cosine of theta. We have calculated that already. And then what is the value of sine of 180 degree minus theta? Well, that is actually sine of theta, positive sine of theta. So now we have a negative of the ratio of cosine over sine, that would be cotangent. So this would be negative of cotangent of theta. So let me make a quick note here. So we have been able to calculate the trigonometric ratios of the angle 180 degree minus theta in terms of the trigonometric ratios of the angle theta. I hope everything made sense. Thank you for watching. See you in the next video.